doing chapter 2.4, absolute value in open sentences. And there are 3 concepts that I want you to understand about this section. The first one is whenever you're dealing with absolute value of an equal sign, okay, you need to know that there's going to be 2 different answers. Because if I have the you have to ask yourself, what can I plug in for x to get 1? Well, you can plug in 1 and you'll get 1, or you can plug in -1 and you're still going to get 1 because it's in absolute values. So you would have 2 different answers, 1 and -1. And when you go to graph those on a number line, they are closed circles because they are equal to those points exactly. And there is one like this on your test, and for some reason people try to highlight things, and there's nothing to highlight because they are those 2 points. So remember, equal sign means they are those 2 points, and you should have 2 answers for any absolute value problem. When you have absolute value of a greater than sign, I say that it's great or, and that's why I spelled this with an or, great or. So whenever you have a greater than sign, it's great or, and it should have the word or in it, and your answer should look like an or. So I would have the absolute value of 1, and, the absolute value of 1. X is greater than 1, or X is less than -1. So these are your 2 answers, and you write one exactly the same and one where you flip the sign and you change if it's a negative, you make it a positive. If it's a positive, you make it a negative. And then you would go ahead and graph those. So you'd have greater than 1, and you'd have an open circle, and it's going to be pointing to the right. And you would have a -1 here, and again it's less than, so it's pointing to the left. And it looks like an or, and it should be an or because it's a great or. The third one is when you have a less than sign. And I try to remember that a less than sign is a less than and, like than and. So these 2 are my little tricks to try to remember if it's an and or an or. So a greater than sign is an or, and a less than and is an and. So we have a less than sign, so you have one that looks exactly the same, and then one where you change the inequality and you change the number. So if it's a positive, you make it a negative. If it's a negative, you make it a positive. And since it's an and, it should be written like this together, as long as your common area overlaps like this. So here, when we had less than 1, we had an open circle and we were going less than 1. Here we had a greater than -1, so open circle, greater than -1. And here was your common area, and it was in between -1 and 1. So you might want to pause and make sure that you have all this copied down, because I'm going to go into our first example. Example number 1. Let's solve an absolute value problem with an equal sign. Okay, we're going to rewrite this so that one of them looks exactly the same, and one where you change and make it a -5. So you're changing the sign. With an equal sign, there's nothing to flip, so it's still an equal sign. You will never change what is inside the absolute values. That is a common mistake. It's only what's on the outside. And before you start to solve this, you always want to make sure that you have the absolute values by themselves. So the first couple ones that I do, they will be by themselves, and then I'll show you one that doesn't look like that. So you can solve this into 2 different equations, and you would just solve them algebraically. You would subtract 3. You'd have 2s equals 2, divide by 2, s equals 1. Come over here, subtract 3. You have 2s equals -8, divide by 2, s equals -4. And you would graph those on a number line, and these would be your answers, this one and this one, and they are equal to those numbers. So here's -4, so it's a closed circle because it is that number, and 1 because it is that number, and I always like to put where 0 is. So for me, you need to have at least 3 points on there so that I know exactly where your graph is for the test. Example number 2. Let's do one that's a less than. So I have 3 minus k is less than 2. So it's a less than and. So this should look like an and. So we are looking for the common area. I'm going to rewrite one that looks exactly the same, and then one where I change the inequality and I change the number sign. Again, you're not changing what's in the absolute values. And then you go ahead and solve. You subtract 3. You have -k is less than -1. You're going to divide by a -1. And remember, when you divide by a -1, you must change the inequality sign. So it's going to be a positive k is greater than a positive 1. There's your first answer. Then you're going to subtract 3 over here. I have -k is greater than -5. Again, I'm dividing by -1, so you have to flip the inequality sign, and I get a positive 5. So you know it should be an and, so when you go to graph this, you're going to have 0, 1, open circle, and it's greater than 1. You'll have 5, open circle, and it's less than 5. Since it's an and, you're looking for the common area, and that is the common area. And remember, you must write these together. And the easiest way is these point to the left, and you just bring them down. It works every time. Example number 3. Let's do an or. (2w minus 5 is greater than 7. Now I must point out something really important. For my tricks up here to work with the great or, less than, and, the absolute value must be on the left. So again, when I taught you the trick about shading, like here the arrow's pointing to the right, and so that means you're going to shade to the right. Remember I said the X had to be on the left. The same goes for these tricks. Okay, so if for some reason the absolute value was not on the left, you'd have to rewrite it so it was. So here it's on the left. If it was written like this, just for an example, these mean the same thing, but this would look like a less than, and that would look like an and, but it's not because we have to have this on the left. So just remember that when you're using my tricks for your classwork tomorrow. Okay, so we're going to go ahead and solve this, and it's a great or, so you know that you're looking for an or, and you're going to write one exactly the same, and then one where you're going to flip the inequality and change the sign, and then you go ahead and solve. Divide by 2, w is greater than 6. Come over here, add 5. You have 2w is less than -2. Divide by 2. W is less than -1. So here's your or, and you write it with the word or, and then you would graph it. You're going to have -1, open circle, and it's less than. You're going to have, let's put 0 here, 6, open circle, and it's greater than 6. So when you go to highlight this, it does look like an or. example number 4. Absolute value of 2t minus 3 plus 2, and we're going to make this equals 5. Now, the absolute value is not by itself. So you cannot rewrite this problem into two different equations until you get rid of this 2. So you can't make it a negative 5 yet. Here's what happens. When we get rid of the 2, you'll have 2t minus 3 in absolute value signs equals 3. And now you can rewrite your equation. The same goes if this was an inequality sign. So we're going to have 2t minus 3 equals 3, and 2t minus 3 equals negative 3. And you go ahead and solve these. You get 2t equals 6, divide by 2, t equals 3, add 3, they both go away, you have 2t equals 0, when you divide by 2, you still get 0. So these are your answers. And again, when you graph it on a number line, you would have 0 and 3. And since you have to have one more point, I would just write negative 1 so I can see where your number line is. So these are the 4 examples that I wanted to do with you. I need to point out that you still have all real numbers and no solutions. Okay, so if you have something that should look like an or, okay, and because it's a greater than sign, so if it should be an or, and it ends up looking not like that, okay, you still have to use your no solution and all real number rules. So for example, if you knew that you were going to have something that should look like an or, and when you drew it, it looks like this. Remember, this is all real numbers, and you would highlight everything for the graph. So if it was supposed to be an or because it was a greater than sign, remember that's all real numbers. If you had something that was supposed to be an and you would know because it's a less than and you got something like this, you would know that there is no common area, so you would write no solution. Okay? So just to make sure you remember those rules, just like before in chapter 2.2.